Hello and welcome to Not a Buffalo, the show where we discuss the science and technology that will save the world. My name's Ben and I aim to be the 478th man on the moon. This is Jack and he thinks the moon is just the back of the sun. Jack, how are you?
How many people have been to the moon?
So far I think it's 13 or 14.
Oh, you're higher than 400 and whatever it was.
I just want to be realistic. I've got some time. I don't want to set my sights too high, but I do want to get on the moon, which I think is setting my sights pretty high enough, so...
Well, the moon is high up. Is it like a specific ordinal number you're aiming for there, or do you have like a range?
No, I specifically want to be 478th. I like the number. I mean, if I was 477th, that'd be no good. 476th would be fine, but only really in that range.
Only even numbers?
Only even numbers, yes.
Okay.
I presumed that, in fact, maybe it is 14, because... Oh no, they did set... The first mission was 3 people. I was about to say, maybe they only ever send... Because they always send people onto the moon in pairs in case they get lonely, because it's a very lonely place, the moon, I presume. So maybe that's... maybe it's always in even numbers anyway. Maybe you can't be the 477th person on the moon, or maybe they do just count one at a time as they step onto the moon.
Oh, so we're actually counting like the people who like put a boot on the moon, not just people in the capsule.
Yes, they have to have actually been... They have to have a footprint on the moon. You know what they say? Footprint in moon dust, or it didn't happen. I don't know who says that.
Are we going to make this into a conspiracy podcast?
I love the I love that that joke. Did you know they got Stanley Kubrick to fake the moon landing, but he's such a perfectionist he insisted they do it on site. We're very soon going to be celebrating the 50th anniversary of the Apollo 11 mission of Not a Buffalo and of Apollo 11 successfully landing on the moon. So Jack, do you have any astronomy or space stories for us this week?
Yeah, you know what? I've got a space story that's also a history story.
Fantastic. Kills two birds with one stone. Go ahead.
A Chinese and Japanese team of astrophysicists working in Tibet recorded the highest energy photons ever seen, which is cool in itself.
Wow, okay.
450 trillion electron volts, which is a very large number, which very few people can sort of go, oh yeah, I know what that means, including me. I don't really know what 450 trillion electron volts.
It means you can make a lot of popcorn.
I'm not sure it actually does. But what's kind of fun about this is it's traced back to an explosion in the Crab Nebula. It happened in 1054 AD. The event is known as SN 1054, and it was visible in like completely broad daylight right the way for a couple of days through the summer of 1054, like across Europe and the US and China. In fact, they wrote down records of it in China, which is kind of cool. In fact, it was around the time they were developing the first paper money in China, which is kind of amazing. But yeah, the pulses from it are still visible. In fact, the hum of the explosion and the radiation from that can still be picked up today by the Jodrell Bank Observatory in the UK, which is kind of cool. So you can go and listen to it.
Wow. That's really cool.
Yeah, it's awesome. It's like listening to a ghost.
I have to say, Jodrell Bank is one of the things that really got me interested in science, because it's very near where I grew up, and we went on a school trip there to have a look around, and I mean, it's just these huge dishes looking out into space, but the person who's giving us a tour explained it very well in a very engaging way, and I think they were looking at pulsars, and they showed us a simulation of a pulsar and the sound that they could hear through these telescopes, and it's just amazing, really amazing experience. And highly recommend, if you get the chance, to go and go along to Jodrell Bank and hear and experience some of these things from the depths of the universe.
Yeah, it is a fantastic place, and it looks like a proper sci-fi film observatory, doesn't it? With like the giant because the dishes were actually made from Scunthorpe steel.
Really?
They were UK sourced back when Scunthorpe and Tata Steel were in a slightly better place than they are today. I think Tata Steel's doing okay. I think British Steel is not doing so well.
Yeah, I'm pretty sure British Steel, they made a big fuss about saving it, and then they're going to leave anyway because of Brexit. I think in 2014 or 2015, they almost went bankrupt, so the government stepped in and saved them to save all the jobs, and then 2 years later, they said, okay, well, you Brexited, so we're getting out of here.
We almost went 10 minutes without mentioning Brexit.
I know, we did so well. We were doing so well. Okay, never again. We're talking about NASA and NASA's achievements here.
Yeah, and Nexit, which is where NASA go off-world.
Speaking of going off-world, you've probably heard of NASA's Voyagers 1 and 2 spacecraft. Are you familiar with them?
I've read about them.
So they were launched in 1977, so 42 years ago, and they've been going longer than any other spacecraft in history. But they're in the news recently because the NASA engineers want to keep them going even longer. So they're now 18 billion miles from Earth. 11 billion miles, 18 billion kilometers from the sun. And so they're getting pretty cold, and it's getting quite the batteries are running low. And so NASA is basically looking at ways that they can send a signal to them to basically send them a patch so that they can maximize their energy usage and conserve it and try and be as efficient as possible to ensure that they can carry on sending back information for many more years to come. So yeah, these two. I mean, it just. The fact that we landed on the moon in 1969, I think, is mind-blowing. But the fact that they've sent out these two spacecraft 42 years ago, and they're still going and still sending us back information, and they're 18 billion kilometers away, I find almost more staggering. Like, I can see the moon, but I can't even imagine where these spacecraft are.
Also, like the fact that we loaded up a gold record on them as well,
yes,
which is kind of cool.
Did you see in the news, just sticking with the space theme, that Emmanuel Macron, the president of France, for those who don't know, and no, he's not a macaroon, and no, he's not a macaron, he is Emmanuel Macron, and he wants to have a space force, French space force. I think he's going to call it the exact same thing. But yeah, he announced, I've not got a story in front of me actually, but he said he wanted to create
such a French thing to do.
I can only imagine that they kind of want to be able to go up and just watch the Americans make a fool of themselves, and they're just going to go up there and be sipping coffee and eating pastries and watching the Americans run around and shoot each other with laser guns.
And eating macarons.
And eating macarons, yes. Apparently they're going to spend, I can't remember, again, I don't have the number in front of me, but it was several billion euros on creating the Space Force, and apparently it's going to be...
this must be an ESA initiative, though, right?
No, because it's a national security initiative. They're doing it for national security.
How on earth is France going to fund this?
France has money. They're going to start taxing airlines now, so they're going to put the money into space instead.
Oh, okay. Makes sense. Tax aerospace to make aerospace.
Exactly. Because why get cheap flights to Malaga when you could have a satellite with a laser on it? Or Space Marines.
You could do that without... Yeah, Space Marines, sure. Am I for that? I'm not sure. I like half of it and I dislike the other half.
I'm for space explorers, but I don't want to give them guns. Particularly not laser guns that might actually work in space. How would shooting a gun work in space? You'd go really far. You'd be thrown back really far, wouldn't you?
Yes.
And then
yes, you would.
The bullet would just keep going, presumably. Or would it? Yeah, there's nothing to slow it down, so the bullet would just keep going and going and going.
Yeah, I mean, the bullet would be caught by the gravity of some kind of body, probably the Earth, actually.
And then just orbit it until it hits someone. It would depend on where you were when you shot it, I presume, and in which direction. Like if you shot it towards Earth or away from Earth as well.
Yeah, I mean, even if you fire it away from Earth, it won't escape the solar system. Like, gravity is very weak, but it's pretty persistent as forces go. That's why there's so few objects that have actually left our solar system or are even able to leave our solar system.
Yeah, and why you have those comets that come round every couple of 100 years because they're just in a very, very big orbit, but they are still orbiting.
I revisited something I read ages ago about the Great Attractor. Do you know the Great Attractor?
The Great Attractor? What, Don Juan?
Don Juan in space. I think we found our episode title.
Yes, yes, absolutely.
The Great Attractor it's this gravitational force which sits behind. If you look up at the sky and you see the Milky Way, you're effectively looking through our galaxy, which is a disk that we're on the edge of. So you're looking right the way through the disk of stars. On the other side of that, there's something very gravitationally massive. Which is pulling us towards it, and we've got no idea what it is.
On the other side of the Milky Way?
Yeah.
Is that not just another galaxy, or is it this dark energy, dark matter that I keep hearing about, but that no one has an idea what it is?
We don't really know. There is a large cluster of galaxies further away. Now we think that maybe that might be what's pulling us there, but there is definitely some big gravitational mass pulling us towards it. And the reason this was discovered in the first place was because I think back in the 80s or something, astronomers were trying to calculate what direction should we be going if we've only got Hubble's flow going on, which is the expansion of the universe, and which way we got thrown after the Big Bang. That's where all this stuff about like the local group and stuff like that, which is what we're gravitationally bound to, came out of. But there is an anomaly, which they call the Great Attractor, which sits on the other side of the Milky Way, and no one has any clue what it really is. Like, you can look at that with infrared and X-rays and stuff like that, but it's very imperfect and it doesn't really give a clear picture as to what it is.
Wow.
It's one of those mysteries in astronomy that nobody really talks about because it's
terrifying.
It's been known for so long, and it does also sound like the beginning to a dystopian sci-fi where aliens are just hauling our galaxy away to be thrown in the tip.
That's all our galaxy is good for.
Yeah, possibly. It's perfect. Maybe it's produced insufficient life.
Maybe.
Like most galaxies breed 50, 60 stellar civilizations in this time frame. This one's clearly not good enough. It's only bred one that communicate by radio waves.
That is such a weird thought. Yeah, we could just be as insignificant to another life form as amoebas are to us.
Mm.
Well, on that cheery note, do you have another story for us?
Oh, yeah. Upbeat stories, right? So this one sounds like it could be used in a dystopian novel, but it's actually kind of fun and kind of sci-fi and cool. They're calling it deep identification, with I spelt EYE, but it's for identifying people. This team in University of Potsdam in Germany have found a way of identifying people not by the colour or shape or consistency of their eye, but by its movements.
Okay.
And this is an approach that's been tried a few times before and never really yielded anything. But what they've done is they feed the raw data, which is the samples are very high detail and high frequency. So it's about 1,000 frames a second. And it's an HD camera or something along those lines. They feed this into a deep learning architecture, and that's able to quite reliably identify people from the way that their eye moves around. And it comes out of this finding in cognitive psychology, which is that from individual to individual, eye movements are relatively stable over time, and they're also largely independent of what the person's looking at. This is specifically micro eye movements. So if you're focusing on something, then your eye still moves around and twitches a little bit. And if you have a super high frequency camera, then you can pick up these tiny little movements that happen within literally fractions of seconds. And you can use it to identify people.
Wow, that's really weird, because I was just listening to another podcast today where they were talking about how eye tracking is going to start becoming a feature in phones for advertising purposes. So they can track what your eyes look at and how long they're lingering over adverts, and they're going to start putting this into webcams and into phones, and essentially use this technology. And they were talking about how this could be a very dystopian.
It is very dystopian.
But the fact that there's that kind of identification thing, and presumably the benefits of that identification is that you don't get any racial discrimination or anything. It's a way of checking someone's identity without confirming their race or ethnicity or anything like that could bias the person checking the identity.
Yeah, I mean, it's probably pretty cheap if you think about it. I mean, camera technology is not super expensive anymore. Deep learning is hard to train, but once you've trained it, it's all good. They have some really cool graphics in their paper and some very long equations.
We do love long equations here.
We do?
Yes, we do. Okay. Well, we're going to say we do. Just don't test us on it, listeners. You like long equations, don't you, Jack? I'm not particularly au fait with long equations, but I think you like long equations, don't you?
I like getting to know how things work. If I have to go through a long equation to achieve that, I'm perfectly willing to. I don't tend to read the equations for podcasts. That's my terrible secret of this podcast. Is I don't read the equations. Ben reads them and then tells me what they mean.
I tell you what they say. I don't think I tell you what they mean. I did see, it's not even an equation. This isn't really this is a terrible segue. But you know Alan Turing is going to appear on the new £50 note in the UK.
Yeah, I saw that. I'm really happy with that.
Apparently they've got some binary script on it.
Funky.
Which actually translates into, I think... It translates into 23/06/1912. Yes, 23/06/1912. I got that right. Which is Alan Turing's birthday.
Oh,
so
that's nice.
He's got his birthday in binary on the note right next to him, which is quite cool. But it's a nice little detail they added on. Yeah, that's not really an equation at all. It's just a long binary number. So I'm sorry, I completely failed in my segue there.
So is the segue to binary? Or was that the story?
That was just
the
the
Alan
story.
Turing?
I actually do have more stories about the technology that NASA has brought us. This article was talking about the 50-year celebration, which is actually happening on the 20th of July. So a few days
cool.
have already happened by the time this episode comes out. But on the 20th of July,
Are you going to be celebrating it?
I will probably read some of the articles and go, that's quite cool, but probably not doing much else for it. But
It's a Saturday, isn't it?
Yes, that is a Saturday. Oh, maybe just go out on a crazy party.
You could go to space.
Could go to space if that. Maybe if Jeff Bezos ever gets back to me and accepts my friend request on Facebook, then maybe I would go to space. But so far, he's just been ignoring me. But NASA, one of the things NASA developed was a small, lightweight unit that purified water for human spaceflight, because obviously fresh drinking water is kind of useful when you're in space or at any time.
That's useful.
And they use silver ions to kill bacteria, because apparently they worked very well. But we now use it on Earth for things like cooling towers and also even in pool cleaning technology. So the next time you go in a pool or go to a spa, you may be using NASA technology to enjoy that water.
That's also what they do for cloud seeding, isn't it? They sprinkle silver ions into clouds.
Is that silver ions or silver nitrate? It's silver something.
This is how I segue into conspiracy theories. It's cloud seeding.
Chemtrails, yo.
DARPA. They're out to get us, Ben. Yeah.
But let's carry on anyway. I mean, get all the information out there whilst we can before they get us. I mean, I've got my window wide open because it's quite warm, so it's not going to be difficult for them to get in and get me, but I'm going to keep going anyway.
Do you think the national parks are hiding something? Lots of people go missing in national parks every year.
No, but did you know there's a bit of Yellowstone Park where there's technically no law, so you're allowed to murder people?
Has anyone ever tried?
I don't think so.
I have a vague recollection that there was like an urban myth that there was a lawyer or something who murdered someone.
There was a lawyer who claimed he could and was asking them to close the loophole because he's that kind of pedantic guy.
That does sound like a fun person to say.
Yeah, so there's I think it's in Yellowstone National Park. The Yellowstone Zone of Death, as it's popularly called, and as a result of a loophole in the Constitution of the United States, it's because the park is governed by Wyoming, but the land is technically in Idaho or something like that.
What? That's odd.
Let me read it out.
How'd that happen?
The court district governing Wyoming is currently the only court district in the US to have jurisdiction over land in other states. This is due to the fact that all of Yellowstone National Park, which includes part of Wyoming, Idaho, and Montana, is part of the Wyoming Judicial District. Any criminal discovered to have committed a crime in that district will usually be brought to Cheyenne, Wyoming, where the court for the Wyoming district is. However, the Sixth Amendment to the United States Constitution decrees that a trial must happen both within the district and state of where the crime was committed. Because of this, a crime committed in the zone of death would be constitutionally required to be tried in and include only jury members from zone.
That is such a beautiful geographic set theory problem. That's wonderful. Because it's so obvious where the loophole is as well.
And the reason you can't be tried there is because it's uninhabited, so you can't assemble a jury. So the criminal would be unable to have a fair trial, meaning that they could not receive any legal punishment for major crimes.
That's a fantastic... I'd heard about it before, but I had no idea it was so blatant.
For anyone getting a bright idea out there, I probably should mention that...
Yeah, don't murder.
In reality... don't murder, but in reality, the court will probably just declare, yes, you can be tried in this specific case in Wyoming or in Idaho or wherever they would do it. They probably would find a way around it and declare the Constitution wasn't meant to be used to commit murder.
You say Idaho, I say Idaho.
No, I say Idaho. Or Potato Land.
Hi, America. We love you, really.
Hey, I'm talking as an Irish person. I feel a great affinity to Idaho.
See, I feel this would work better if you sounded Irish. Would you like to say something offensive about Idaho in an Irish accent?
I don't know how to insult people in Irish.
But do you know how to say potato and land in Irish?
Actually, no. I can't remember.
Oh.
The only thing I can ever really remember how to say in Irish is "Tá coppla focal gaeilge gom," which means I have a couple of words of Irish. And literally a couple of words.
It's such a wonderfully musical language, isn't it?
It is. It's nice to listen to, and I've come to realise it looks really complicated and makes no sense to an English speaker. But then when you actually look at the rules, it's way more sensible than English is. In Irish, you always there's a rule for how you pronounce things. So, for example, if it's an MH, if is following a long vowel, you pronounce it one way, and if it's following a short vowel, you pronounce it another way. And the long vowels are like ah, but the short vowel would be like eh, for example. I'm probably getting that completely wrong. But you always pronounce everything the same way, even if some of the pronunciations are weird, like in Neve, where MH makes a V sound. But in English, obviously things just change all the time just for the hell of it. Things like rough and though that don't rhyme when they should. And I think Italian speakers get really annoyed with our sound because we have so many ways of saying like you have lead as in LED, le as in leopard, so EO makes the sound, dead, so EA makes the sound. And then you have as in friend, so EI makes, IE even makes an sound. But then they can also be completely different. Like you can have friend is but then fried is I, and Leo instead of leopard, or reed instead of dead. And it's just why do we? This is so.
It's a nightmare. Yeah. It's a nightmare of a pronunciation language.
Yeah, it's a very silly language, and it's something I've only kind of just come to realise, having learnt Irish and thought it was nonsensical. But like, actually, they've sorted out a much better system than the English ever did.
This is actually what drew me to German. Is like the pronunciation isn't massively easy, but it's consistent.
That is so helpful. Once you underestimate how much you learn, how helpful that is once you've learned the rules and just being able to pronounce things. Because when it comes to another language and you don't have that, it is a nightmare. The thing that still gets me and still annoys me about a German, and German in particular, is the genders. Just having to know the gender of a table or of a flower or of a blind or a window. I'm definitely not just looking around the room here. It's just a pain.
Yeah, you have to memorize the article with the word. There isn't really another way to do it. You can memorize the endings to words in German, because the article is most of the time consistent for certain endings.
I have to say, I've not tried speaking German for a long time, but I actually went back onto Duolingo the other day to start learning a bit more French.
Oh, nice.
So anyway, I managed to get through. So far, I managed to get through one of these amazing technologies that NASA gave us, and I have 3 more to go.
I didn't realise I'd diverted you so effectively.
No, you did a good job. But
Thank you.
The second, so these other 3 things that kind of we use very widely on Earth now. The second thing is breathing masks, such as what the US fire chiefs.
Oh, wow.
As in firefighters, what firefighters use. Sorry, because apparently what they used to have was about 30 kilos of breathing gear, which meant that some of them just dropped it and held a handkerchief over their mouth when they were trying to reach the fire, because that's really annoying trying to carry a person out of a burning building and also carry 30 kilograms of breathing gear, as you can imagine. And then they also started using polymer fabric, again, which was used by firefighters to create the fire-resistant materials and their protective gear. And then finally, something that we could not do without today is cordless devices.
No way!
Yeah, so when they wanted to take measurements, they obviously couldn't trail like an extension cable out of the Eagle Lander so they could drill up moon rocks and things. So they worked with Black & Decker to develop cordless electric power tools, essentially.
Oh, right. So we're more talking about tools and drills and stuff like that, rather than, because I was thinking about radios, because I was like, wireless radios existed before NASA.
Yes, yeah, wireless radios did, but I think it was more the things that they typically just plugged in, but obviously now
with high power things, isn't it? It's high power consumption stuff.
So learning how to make efficient batteries that weren't, the size of a car, and that probably has led down the line now to much smaller and more compact batteries, and maybe even the possibility for us having mobile phones all started from here, because obviously they started looking into making battery technology small and portable.
Interesting how the all of Elon Musk's technology companies kind of overlap. I'm thinking about the Powerwall and his rocket ships.
Oh yeah, he's definitely, all of his companies can definitely come together and build a self-sufficient moon base when he gets around to it. I'm sure he just needs to buy like a 3D printing company, which he probably already owns somewhere, and then he's done. He can build his moon base. Or his Mars base, even. You
get the sense that the moon base would just be like a holiday project for him. It would be something he'd do over summer.
Just to prove he could.
Yeah, just to see, I haven't done this. I read a biography of him. I don't know if it's the only one, but it was pretty good. It was by a guy called Ashley Vance. A couple of years out of date now, but still really, really good and quite thorough on bits of his life that I've not read about before.
Okay, I know a little bit about him. I think the main thing I read is that everyone says he's one of the most intelligent and driven people they've ever worked with. That's kind of the main thing I've learned about him, and that he's a really erratic and eccentric tweeter. Everyone says he is ridiculously intelligent, and I kind of always think of him as the CEO and the businessman, but kind of forget that he actually has a background in engineering, doesn't he? And he knows his stuff in that regard as well.
Yeah, I mean, and he also taught himself to do that. When he set up SpaceX, he had a real problem because, you know, he was just like this lone guy trying to set up a rocket company. No one had done it, and so nobody wanted to work for him. So he went away and he just memorized a bunch of rocketry textbooks, and he sort of had to do bits of the staff training like on his own until he got a large enough staff. He personally interviewed, I think, the first 1,000 employees, almost every single one of them.
Wow. And did he make that after Tesla? Was he trying to run Tesla at the same time?
He was running Tesla at the same time, yeah.
Wow.
I think he set them up at a similar time, because he did both of them with the money he got from the PayPal buyout.
Yes.
That's where he actually made his money. Well, where he made the first big chunk of it, and then he started investing it in rockets, which is a surefire way to convince your friends that you've got both feet on the ground. I really recommend the biography. It's really good.
Well, actually, there's been some new technology that might help him with his space dreams that they're currently testing at the University of Colorado.
I'm in a segue again, aren't I?
This will be my last story, but you're probably aware that astronauts have a real problem with bone loss, muscle loss, cardiovascular deconditioning, and everything when they're in low gravity or zero gravity environments. But they found a way that rather than... You've probably seen from sci-fi films these massive spinning spaceships that create artificial gravity. Well, they've realised that's a bit unfeasible given the size of the spaceship you'd need. But they have found that astronauts... They think that astronauts could basically have a gravity spa and get their daily dose of gravity, so they don't need artificial gravity all the time.
So they just put them in a fast spinning.
Yeah, and it doesn't have to be that big. It's like just big enough for a person to kind of sit on, and then it's just a spinning wheel, essentially. And you put them in that for a while, and then they. But generally, I've got the picture here, and there's a video which we can share on the social media later on. But it's basically the size of a table that a grown man can lie down on, with kind of a circular table, and then what looks like a ladder coming off it as well, and they just they spin you around on that, and that kind of gives you your daily dose of gravity. They're still working on it and trying to combat how they can deal with the motion sickness and everything. But the point of the research at the moment is trying to find a way to make it tolerable and be able to do it, on a regular basis, day in, day out. But it's looking quite promising at the moment, and they think they might have found a way that they could ensure astronauts can stay up in space for longer. For example, if they wanted to go on a mission to Mars, which I think would take, I think we discussed it on this podcast previously, but it'd take 4 to 6 years or something on a spaceship to get there under the present technology.
That's really cool.
I'll be that 478th man on the moon yet.
Do you think you'll ever go to Mars?
I don't know if I'll ever make it to Mars. I want to be optimistic and say that we are going to start taking... I think the planet is I think we're going to see a lot of damage happen to the planet, but I think we will take it seriously enough that we can save the planet. Or we will find a way to adapt and continue to live on Earth.
I mean, I certainly hope that we can save the planet.
Yeah.
There isn't really a backup option at the moment.
Exactly. But I think we're more likely to save the planet than we are to set up a new colony on Mars and live on Mars. In our lifetimes, anyway. We might see the first man on Mars in my lifetime, but I doubt we'll see anything beyond a kind of trip there and maybe even a one-way trip there.
I don't know. I think some kind of colony on Mars is doable in our lifetimes.
I mean, how long we've probably got? We both look after ourselves, and if medical science and life expectancy...
Yeah, we've got at least 20 years between us.
At least 20 years, did you say?
Between us.
I was going to say maybe 100 years each, but...
Yeah.
Yeah, as I said, if we continue to look after ourselves and if life expectancy continues to go up, we could easily live to be into our 120s, 130s. Maybe we'll just end up as cyborgs and be brains in a jar, and then we'll live forever.
I don't know if I'd want to live to 120.
If I could be as healthy as my 90-year-old gran is when I'm 120, I'd be happy, because she is
a badass.
She is. She can still drink anyone under the table, still lives by herself, and just doesn't give a damn anymore, and will happily tell everyone what she thinks, which is great.
I'm so glad you avoided mentioning Brexit there. So I'm going to mention it. Brexit.
Why? We've done so well. We've gone like half an hour without mentioning
Which
it.
is a long time for us in conversation.
It does feel like it's just this looming monstrosity. And I don't know why. It is because the Tory leadership contest, but it feels like something... I know nothing's really going to be decided until October and probably even after that, but it does feel like in the next couple of weeks or whenever the dust settles and we have a new Prime Minister that something big is going to happen.
I don't think anything big is going to happen with it because new Prime Minister comes in on, 23rd, 24th? And then the day after that, it's 24th or 25th, Parliament goes on holiday until September. So...
Yeah, good point.
So, unless they manage to pass something, in the space of 24 hours, there's not much that can happen.
Good point. Anyway, I'm going to leave it there. Do you have any more stories for us? Anything else you want to share?
The only other story I had was that, what spooky action at a distance is?
I've heard of it. I can't remember off the top of my head.
It's what Einstein called quantum entanglement. It's this weird property of particles which, when they're usually under a super cooled environment, their natures, for want of a better word, become entangled. And then no matter how far you separate them, if one of them turns, say, left, the other one turns left as well. If one of them emits a photon, then the other one will also emit a photon, and they become synced like that until the quantum entanglement is broken. But what's kind of fun is that they managed to photograph this for the first time.
They managed to photograph it? Wow.
Yeah,
how did they do
with
that?
A camera.
Just like an iPhone?
No, it's like I think it's an electron microscope or something like that they've used because it's below the realm where colour actually exists. There isn't really colour at that resolution. We can probably put a link to the article in the show notes. Thank you very much for listening. Please subscribe to the show to never miss an episode and rate and review us wherever you have the power to do so. If you'd like to get in touch, we are at Not a Buffalo Pod on Twitter, Not a Buffalo Podcast on Facebook, or contact us through the website notabuffalo.wordpress.com. Bye.
Bye-bye.